Welcome to edupediaworld.com. You're watching the videos on areas of parallelograms and triangles. So in this video we'll discuss more questions related to areas of parallelogram and triangles, which are very important from the exam point of view. So you have to again watch this video very carefully. Okay, now let's get started with the first question, question number 1. Now the question number 1 says that D, E, F are respectively the midpoints of side BC, CA and AB of triangle ABC. So we need to prove that BDEF is a parallelogram and area of DEF is 1/4 the area of ABC and area of BDEF is half the area of ABC. So let's see how we can prove this. So first we need to draw a triangle. So let's say we have a triangle like this. It's A, BC, and we have midpoints. Let's say D over here and E over here and F over here. Okay, now let's join these points like this, right? Now, so let's see how we can prove this. Now, if you can see properly, F and E are the midpoints. If a line joining the midpoints, according to midpoint theorem, as you can remember that if we join the two midpoints of any two sides of a triangle, so that side, the line joining the midpoint will be parallel to the third side and it will be half of the third side. So we can say that FE will be parallel to BC and FE will be half of BC. We can say according to midpoint theorem. Right? So now similarly we can say that FE will also be parallel to BD. Now we can say that again FE will be equals to BD. Why? Because D is a midpoint. It's given D is a midpoint and BD will be again half of BC. So we can say that FE is equals to BD and FE is parallel to BD. So we can say that again BDEF is a parallelogram. It's a parallelogram. Why? One pair of opposite sides are equal and parallel, right? Now if this is a parallelogram, we can say that then this area equals to this area. So we can say that area of BDF equals to area of FED, right? Similarly, if you consider this again, FE is again parallel to CD and FE is also equals to CD, right? So we can say that again according to midpoint theorem, again midpoint theorem, right? So again we can say that FECD is a parallelogram, right? So means this area will be equals to this area. So we can say that area. So why these two areas are equal? Because as we know, if this is a parallelogram, the diagonal DE divides the area into two equal halves. So we can say that area of DEF will be equals to area of DEC. Similarly, if you look at this figure again, this is again a parallelogram, right? Since these are the two midpoints, F and D, and the line joining the midpoint is parallel to the third side and it's a half of third side. So we can say that again FD is parallel to AE and FD is half of AC, or we can say that FD is also equals to AE, right? So again AEDEF is a parallelogram. So we can say that then this area equals to this area. Why? Because this, if this is a parallelogram, FE will bisect this into two equal areas, right? So we can say that area of AEF will be equals to area of DEF. So let this be first, let this be second, and let this be third, right? Now we can say that properly that area of DEF is equals to area of BDF equals to area of DEC equals to area of AEF, means all the four areas are equal. So we can say that area of DEF is 1/4 the area of ABC. So this is how we can prove this part. Now the last part says that we need to prove that area of BDEF is half the area of ABC. So let's see how we can prove this. Now since we know that BDEF is a parallelogram, and we can say that area of DEF is half the area of BDEF. Why? Because the diagonal divides the area into two equal halves, right? So we can say that then area of BDEF is 2 times the area of DEF, right? So we can say that area of BDEF equals to 2 into, now we have area of DEF equals to 1/4 the area of ABC. So we can say that it's 1/4 the area of ABC, right? So it will be area of BDEF will be half the area of ABC. So this is how we can prove questions. So let's move on to the next question, question number 2. Now the question number 2 says that in figure the diagonal AC and BD of a quadrilateral ABCD intersect at O such that OB equals to OD and AB equals to CD. It's given. So we need to prove that area of DOC, this area, equals to this area, and we need to prove that area of DCB, this area, equals to area of ACB, right? Then we need to prove that ABCD is a parallelogram. So let's see how we can do this. So for construction, what we need to do is we need to draw perpendicular from D over here and perpendicular from B over here, right? Now so we can write over here construction, draw perpendicular from D and B on AC, right? Now if you consider triangle D, so let's say this is point E and this is point F now, right? So if you consider triangle DOE and triangle, let's say BOF, so in this triangle angle E equals to angle F. Why? Each 90 degree, right? And angle DOE equals to angle, let's say BOF. We can say vertically opposite angles, right? And we can say that DO equals to OB. It's given, right? So we can say that triangle DOE is congruent to triangle BOF, right? So we can say that this side equals to this side. We can say that then DE equals to FB by CPCT, right? Now again, if you consider triangle DEC and triangle AFB. So we can say again that angle E equals to angle F, each 90 degree, and DE equals to FB. We have proved, right? Then we have CD equals to AB. It's given. So we can say that triangle DEC is congruent to triangle AFB by RHS, right? Now, so we can say that CD is equals to AB, it's given, and CD is also parallel to AB. So if one pair of opposite sides are equal and parallel, so it's a parallelogram. So we can say that ABCD is a parallelogram, right? Now what we need to prove is, we need to prove that area of DOC equals to area of AOB. Now, if this is a parallelogram, so we can prove these two triangles are congruent. How? Let's say this angle equals to this angle, and this side equals to this side, and this side equals to this side, since the diagonals bisect each other. So we can say that these two triangles are congruent. So we can say that consider triangle DOC and triangle AOB. So in this triangle, angle DOC equals to angle AOB. They are vertically opposite angles, and DO equals to OB and OC equals to OA, since these are the diagonals of parallelogram, right? So we can say that triangle DOC is congruent to triangle AOB by SAS, right? So we can say that if the two triangles are congruent, then the areas are equal. So we can say that area of DOC is equals to area of AOB. Now we need to prove this area of DCB equals to area of ACB. So it's very interesting. If you can see properly, let me use another pen. Now if you can see properly, this is the triangle DCB and this is a triangle ACB, right? Now if you can see properly, these both the triangle lie on the same base BC, and they are between the same parallels AD and BC, right? So if the two triangles, so we can say that the areas are equal. Why? Because they lie between same base and they're between same parallel lines, right? So we can say that area of DCB equals to area of ACB. Why? Because they lie same base BC and parallel lines AD is parallel to BC. So these two areas are equal. So this is how we can prove these type of questions. So let's move on to the next question, question number 3. Now the question number 3 says that D and E are the points on AB and AC respectively of triangle ABC such that areas are equal. So area of triangle DBC equals to area of triangle EBC. So we need to prove that DE is parallel to BC. So let's see how we can prove this. So let's say we have a triangle like this. So let's say this is a triangle ABC, right? So let's say this is a point D and this is a point E, right? So let's say this is a side joining, right? So now, so let's say we join this line. So it's given area of DBC is equals to area of EBC. So we need to prove that DE is parallel to BC. Now let's see how we can see. If you can see the figure properly, both the areas DBC and EBC, they share same base. BC, right? Now if this share same base BC, then and the areas are equal. So this means by converse of the theorem, when the two triangles are equal, when they are between the same base and the same parallel lines, so by the converse of theorem, right, we can say that DE should be parallel to BC, right? So by the converse of, we can say that DE is parallel to BC. So let me repeat once again. Since both areas are equal and they are sharing the same base, so if the two triangles are areas are equal and they are sharing the same base, this means the lines should be parallel, means the altitude should be the same. So this is how we can prove these type of questions. So let's move on to the next question, question number 4 of this video, so which is also last question of this video. Now it's given that XY is a line parallel to side BC of triangle ABC. So let's say we have a triangle ABC like this, and let's say this is a triangle ABC, and let's say we have a line XY like this, right? Now if BE means we need to extend this line. Let's say we extend this line like this. So let's say this is E, and let's say this is F, right? Now BE is parallel to AC and CF is parallel to AB. Now we need to prove that area of ABE, so this area equals to area of ACF. Now if you can see properly, A, E, B and C, if you can see properly, so this is a parallelogram. For why this is a parallelogram? Since if you consider A, E, B, C, it's given that BE is parallel to AC and AE is also parallel to BC. So why AE is parallel to BC? Since it's given that XY is parallel to BC, right? Now if opposite sides are parallel, so it's a parallelogram. So we can say that AEBC is a parallelogram. Now if this is a parallelogram, so then this means AB, the diagonal, will divide the parallelogram into two equal areas. So we can say that area of ABE will be equals to area of ABC. Why? Because the diagonal AB will divide into two equal areas, right? Now if you consider figure AFCB, right? Now in this figure we can say that AF is parallel to BC. Again, why? Because XY is parallel to BC. Again we can say that FC is parallel to, let's say, AB, it's given, right? So again we can say that AFCB is a parallelogram. Now if this is a parallelogram, then diagonal AC divides into two equal areas. So we can say that, I'm so sorry for this. Now we can say that area of ABC is equals to area of AFC, right? So let it be 2 and let it be first, right? So from 1 and 2 we can say that area of ABE is equals to area of ACF. So this is how we can prove these type of questions. So thank you once again for watching this video on edupediaworld.com. Keep watching further videos. Have a nice day ahead.